The cosmic void nobody can account for. Right now, a hole nearly a billion light-years wide is still swallowing light, and astronomers at NASA have no way to explain what's inside it. It's called the Eridanus Supervoid, and it sits behind a patch of sky scientists nicknamed the cold spot. That's not a metaphor. It is measurably, mathematically colder than everything around it. Billions of years old, still there, still cold, and the deeper researchers dig, the less sense it makes. But here's what nobody is telling you. What might actually be missing from that spot could change what we think the universe is made of. To understand why this thing terrifies cosmologists, you need to picture the universe as a web. Galaxies cluster along filaments like glowing threads with dark, empty gaps between them. Voids. Normal ones stretch maybe 100 million light-years across. Empty, but not alarming. The Eridanus Supervoid is different. It's nearly 10 times bigger than a typical void, one of the largest structures ever detected. It sits roughly 3 billion light-years from Earth. And when the Planck Space Telescope mapped the afterglow of the Big Bang, the ancient light called the cosmic microwave background, this exact patch of sky came back colder than physics said it should. At first, the explanation seemed simple. Light traveling through a void loses a little energy along the way, cools down slightly. That's normal, expected. Scientists have a name for it, the integrated Sachs-Wolf effect. Case closed, right? Wrong. When researchers actually calculated how much cooling an empty region that size should produce, the number came back too small, nowhere close. The cold spot is roughly 20 times colder than the void alone can explain. 20 times, that's not a rounding error. That's a sign something else is happening in that patch of sky, something current models cannot account for. And here's where it gets stranger. Some of the most detailed supervoid surveys ever conducted have failed to confirm the void is even large enough or empty enough to be the cause at all. So scientists at Harvard at Caltech went looking for a backup explanation. Surely this was a fluke, a statistical accident in a universe full of noise. But the cold spot has now shown up across multiple independent surveys using different telescopes, different data sets, different teams. It keeps appearing in the same place, at the same temperature. A fluke doesn't repeat like that, which forces an uncomfortable question. What if the void isn't the cause of the cold spot at all? What if it's something else hiding behind it? Here's the part they're afraid to say out loud. Some physicists have proposed that the cold spot isn't a void in our universe at all. It's a bruise, a scar left behind from a collision, evidence that our universe once touched another one entirely. The theory is called a bubble collision, born out of models of eternal inflation, where universes form endlessly, side by side, like bubbles in a boiling pot. Under this theory, our bubble brushed against a neighboring one, and the cold spot is the fingerprint left behind. A cosmic bruise pressed into the sky, 3 billion light-years wide, still visible today. Nobody can prove it, but nobody has disproven it either, and that's the part that should unsettle you. A leading peer-reviewed hypothesis for the coldest, emptiest region of observable sky is that it's a wound from a universe touching ours. And the second leading hypothesis is that our entire model of cosmic structure is somehow wrong by a factor of 20. Neither option is comfortable. Both are still on the table, right now. If the void explanation is wrong, it means galaxy formation, structure, dark matter distribution, all of it works differently than the equations currently say. If the bubble collision idea is right, it means we are not alone in the way we've always assumed. Not aliens, something bigger, other universes close enough to leave marks. Either way, the cold spot is quietly telling us that the standard model of cosmology, the one taught in every textbook, the one behind every simulation of how the universe grew, might be missing something fundamental. And it's sitting there in the data, unresolved, waiting for someone to explain it. So the void keeps sitting there. Cold, ancient, unexplained. Telescopes keep staring at it, hoping the next survey finally makes the numbers add up. They haven't yet. So what is actually inside the Eridanus Supervoid, an empty stretch of nothing, or the fingerprint of something we were never supposed to see? Tell me what you think it is down in the comments.